What's up everyone, welcome back to the channel. This time we are still solving a number 3 problem, but this one actually might be harder than what you think. So the question is to prove that for all n natural numbers, so in this case we do not include 0. But in fact, if we include 0, that was the work. We want to show that the expression on the right side, 3 to the exponent 3n plus 3 minus 26n minus 27 is always a multiple of 169. So before we move on and to see the proof, you can pause the video and try to prove it yourself. And if you're ready, we're gonna move on. Are you ready for it? Here we go. So to prove this is true, well, first, outside of the problem, we also said that it will work when n is equal to 0. Well, clearly this is true because if we substitute n equals 0, the term in the middle is gone, and then for the first term here, it will turn out to be 3 times 0 plus 3, meaning the expression here would be 3 to the third power, which is equal to 27, and then subtract to the 27. This whole expression would turn down to be 0, and clearly 0 will be a multiple of any numbers that we want. So in this case, it's kind of not interesting to show when n is equal to 0. Now, how do we prove this is true in general for n positive integer? We are going to use the following way. First, consider the expression 3 to the 3n plus third power minus 26n minus 27. We're going to rewrite this by factoring out the 3 in the exponents and then use the power of power rule that we learned in high school algebra. We will say that this expression here will be same as a 3 to the third power, or raise it to the n plus first power. And in that case, we have 3 to the third power is equal to 27, and then again raise it to n plus first power. Next, we're going to put the 26n to the right, and then we're going to consider the two terms outside. 27n to the n plus first power minus 27. So in this case, we can factor out the 27 such that we have 27 to the nth power minus 1. And now if we're trying to factor this out, if we consider of a to the n power minus b to the n power, we can always factor out a minus b here, and then for the remaining parts, that factor will just be the sum of a to the n a to the k power times b to the n minus k power for for k from 1 to n minus 1. So in this case, we are actually going to factor out the a minus b, which is 27 minus 1, to get a 26. And then for the remaining parts, we'll get, in this case, the sum from k equals 0 all the way up to n minus first power of 27 raised to the kth power. So again, that is saying that b here is just equal to 1, and we can ignore it, and then we'll get from k equals 0 to k to the minus 1. Again, this one should be 0. Here there's a mistake in here. This should be a minus 1 as well. Then we will still have a minus 26n here, and then we can factor out the 26 to get the remaining part. And now we can replace the, we can actually multiply this 27 back in to get the first part will be the sum when k starts from 1 to n of 27 to the kth power minus this n here. So So up to this point, we actually got one of the copies of 13 that we need. Now, why do you want to say that? Because we want to show that it's a multiple of 169. In fact, it is same as 13's square. So now we actually get here is this whole expression is a multiple of 13. So it is now sufficient to show that this is also a multiple of 13, so that we will be able to complete the proof. How do we do it? Let's move on to the next board. So in the last board, we said that we want to show the expression k, the summation from k equals 1 all the way up to n of 27 to the k power minus n here. And to clarify, it will be like this. We want to show that this expression is actually a multiple of 13 as well, such that now if we multiply by 20, this expression with 26, the whole product will now become the multiple of 13 squared, which is 169. And to do that, we actually need to consider the following way. In order to show that this expression is a multiple of 13, we might as well just think it as doing a modulo of 13. So in order, if we do that, we can now reduce 27 into something that is between 0 to 12 under modulo 13. And what would that be? Well, 27 is in fact equal to 2 times 13 plus 1, where remainder is 1. So in fact, it will be congruent to 1 here. And then again, because this is just a sum, we will actually have n terms of 27 raised to the k power, and each 27 to the k power is just congruent to 1 to the k power in this case. Meaning now we just have n copies of 1 adding together. In this case, we just have this summation to be equal to n minus n, and again, that's just equal to 0. In other words, we have just proved that this expression is a multiple of 13. Therefore, the whole expression 27 times this thing, which 26 times this thing, which is the same as our original expression, 3 to the 3n plus a third power minus 26n minus 27, is in fact a multiple of 13 squared, which is equal to 169 as we want.